Alright, so getting into this next video, we're going to take a look at static members of classes. So that's going to include static fields and static methods. So in order to make sure that we understand this distinction between the static fields and methods versus what are known as non-static fields and methods, everything that we've done so far, so all of these fields and methods we have so far, these are non-static. Whereas, one example that we have of a static method would be the main method. So we see this static keyword right here. So of course then the question is, what exactly does that static keyword do? So the best way to describe it is that when we're dealing with non-static fields and methods, these are going to be things that belong to objects of a class. So if we look at this length and width, these two fields that we created, this length and width are going to be unique to each individual object of the rectangle class. So every time I create a new object for the rectangle class, that object will have its own distinct length and width. When I'm dealing with a static field, however, this is going to be something that belongs to the class itself. So that means that all of the objects will essentially share whatever that field happens to be, or whatever value that field happens to hold. This is also going to be true for my static methods. If I try to use a static method, that's going to be something that all of the objects have access to, and it will always do the same thing no matter which object I use it on. Okay, so we'll start off first by doing a quick demonstration of a static field. In order to do this, I'm going to cheat a little bit by making the access specifier for it public, so we can go ahead and just access it directly. So we're going to say public static. I'm going to make this an integer initially, and this is going to be number of rectangles. I want it to be initialized to 0. Okay, so this number of rectangles integer that I'm creating, it's going to be static, meaning that it belongs to the class itself. And the way I'm going to use it is I'm going to, inside of my parameterized constructor, I'm going to include an increment operator on number of rectangles. So we're going to do number of rectangles, say plus plus. And so now, every time I construct a new rectangle, whether that's using the noargs constructor or the parameterized constructor, because I used this on line 9 right here, it's going to end up calling this line right here, and it's going to increment this counter. And the really useful thing about doing that with a static field is that now I can keep track of that counter across multiple objects. So even if I create 3, 4, 10 different rectangles, I can still keep track of the number of rectangles that I've constructed. Okay, so to do a quick demonstration of this, we'll take this code that we have right here. I'm going to go ahead and comment out this line. And we're going to go ahead and do a print statement here. Whoops. And inside of this print statement, I'm going to go ahead and just call this object rect. And then I'm going to just go ahead and directly access my number of rectangles since I made it public. Okay, so I'll go ahead and save that. Come over here and compile it. So compile. We'll then go ahead and run our advanced rectangle demo. And we can see we get the value 1 right now. Okay. So now let's say that I go ahead and add a couple more rectangles to this. I'm going to do 2 more rectangles. For both of these, I'll just use the noargs constructor to keep this short and simple. So I'll have rect2 and rect3. Create 2 more rectangles. And again, I'm only going to use rect on this. Okay, so I want to see what happens when I call for this number of rectangles using the rect object after having created 2 other rectangle objects. So I'll go ahead and let that saved. Come back over here and we'll compile this. And then we'll run it. And we can see that we have the value 3 inside of there. So regardless of the fact that it was 1 by the time I was finished constructing the first rectangle, when I access it right here, after having constructed 3 of these rectangles, that value has changed to 3. And I'm going to go ahead and copy this, paste it down 2 more times, and also show this on 2 and 3. So we'll go ahead and save it like that. Come over here and compile it, and run it. And we can see that for every one of these objects, that value is 3. Okay. But there is a particular convention that we usually want to follow when it comes to static fields and methods, which is that generally, whenever you use one of these, you don't typically want to be calling it on an object. As you can see right here, you can do that. This is a legal thing to do in Java, but it's not typically recommended, since the purpose of these static fields and methods is to use them on the class itself. Usually what we want to do, we'll go ahead and remove these, is instead we want to go ahead and just call it on the class itself. So rather than putting an object here, when we say like object dot, some field or some method, instead we're just going to say class dot and then the field or method. So we're going to do rectangle dot number of rectangles. We'll come over here and we'll compile this again. We have no errors for that. And when we run this, we can still access that 3. And the primary reason we can do this is because this is a static variable or a static field. Okay. So the general purpose of a static field is to use this with some kind of property that is necessary for the class itself rather than just objects of the class. So there's one example that I gave you where I show you the number of instances of the class that we've created. That would be one particular case where it would be pretty handy to do that. Okay. The other thing we'll take a look at is going to be static methods. So one of the first things I'll go ahead and address is we've got this public keyword for our field right now, and of course, because we want to be able to adhere to proper data hiding, it's usually best that we not do this. So I'm going to change this to private. But as soon as I change this to private, if you're doing this from an IDE, you're going to immediately get an error on this line right here, because now we can no longer access number of rectangles since this is a private field. So we need to go ahead and create a method to access it. So right here, underneath get area, at the very bottom of the class implementation, I'm going to go ahead and add another method to this. So this is going to be public static. This will be an int, since the data type of number of rectangles is int. That's what I need to return here. And we're going to say get number of rectangles. Okay. And then right here, I'm going to say return number of rectangles. And one thing to be clear about, since we did just go over it, make sure that you do not try to use this keyword with number of rectangles. If you try to use this within the context of accessing a field, kind of like what we're doing right here, say if you try to do that on line 48, it will give you an error because of the fact that this is being treated as a non-static reference variable for something that is static. So it would actually complain about that if you tried to do that. Okay, so we're going to do this, and then right here, we're going to go ahead and replace this with get number of rectangles. Okay, so this is one demonstration of how we can go about using a static method, is essentially to be able to access or manipulate our static fields. So now, I'll go ahead and clear this. If we compile this and run it, we can now see the 3 this way instead, and we can actually adhere to proper data hiding by doing this. But of course, there's also another useful convention for our static methods, which is that they are generally very useful when we want to create something that we would consider to be sort of like a utility function. So basically, it's going to be something that we don't necessarily use to try to access or manipulate the data of an individual object, and not necessarily for the static fields of a class, but maybe just for some general purpose usage. A pretty good example of this, if we take a look right here, is the math class. So if we make a use out of a particular method for the math class, so we have this class math in the Java API. There are certain methods we can use with it, say like the pow method, for example, which can take 2 values. We can take, the first value is going to be the base, so maybe we do something like 4, and then the second value would be the exponent, so the power that we want to raise it to, which would be 2. So if we do this, we can get the value 16 out of that. And we didn't have to make an object of the math class. Instead, we just called this pow method on the math class itself. So we're going to go ahead and compile this and run it. We could take a quick look at that. So we can see this value 16 right here. So this is what I mean when I say that we would generally create these static methods for these sort of utility functions or general purpose methods. So we can do something similar here. So let's say that in addition to maybe this get area that I have right here that takes no arguments and is used to calculate the area of a specific object of the rectangle class, maybe I also want to go ahead and make a static version of get area. This will also return a double. And the purpose of this one is that I can go ahead and just put in a particular length and width as arguments to the method itself, and then I can just go ahead and use those to just be able to calculate the area of any particular dimensions for a rectangle, just kind of on the fly. So say we have a length and a width, and then right here we're just going to say return length times width. And of course in this particular case, make sure you do not try to use the this keyword, because this is meant to use these two parameters and not the two fields of the rectangle class. And in fact, if you try to use this on by calling it on the rectangle class itself, and you accidentally put the this keyword here, that will give you an error because of the fact that, well, one, it's inside of a static method, and again, we can't do that. Secondly, even if Java did allow you to do that, it wouldn't really make any sense because the class itself has a length and a width that are initialized to 0, so it would never do anything useful. Okay, so once we've done that, we'll go ahead and include one last print statement here. We're going to go ahead and grab our rectangle class, and we want to go ahead and use the getArea method, but instead of using the noargs version of it, we're going to use a version where we put in our own length and width. So let's say we use the same two values we used here. We'll do 4 and 2. So in this case, we're going to do length times width right here for the two fields, and we'll get the value 8. So if we used a rectangle with these dimensions, the area would end up being 8. So we'll compile that and run it, and we can see this 8.0 right here at the very end. Okay. Alright, so at this point, this is going to wrap up everything for looking at static fields and methods. Gives you just a general overview of how they work and the general usage of them. Going into the next couple of videos, we're going to start taking a look at some additional methods that we can introduce in our classes, which include things like the toString method, an equals method, and also a copy method.